There are moments in history that don't just inform you, they challenge what you think is possible. This is one of them. In the middle of some of the hottest landscapes ever inhabited, where summer temperatures could push past 50 degrees Celsius and water itself became a form of wealth, an ancient civilization did something that still unsettles modern engineers. They made ice. Not by accident, not by chance, but by design. They produced it, stored it, and protected it for months under a punishing sun, without electricity, without machinery, without anything we would recognize as modern technology. This wasn't a trick of nature, it was a system. Deliberate, calculated use of physics, architecture, and environmental awareness so precise that it functioned like a natural refrigerator long before refrigeration existed. And what makes this story even more powerful is not just that it worked, but that it worked consistently across centuries. In one of the harshest climates on Earth, today, as modern cities struggle with rising temperatures, failing power grids, and increasing energy demand, the question becomes unavoidable. How did people over 2,000 years ago solve a problem we are still struggling with today? And more importantly, what did they understand about survival that we've forgotten? This is not just history, this is a lesson. The word itself is deceptively simple. In Persian, yak means ice, and chal means pit. At face value, it sounds like nothing more than a storage hole. But that translation hides the sophistication behind the concept. The Yakchal was not merely a place to keep ice, it was an entire system designed to create and preserve cold in an environment defined by heat. For ancient Persian societies, ice was not a luxury in the modern sense. It was a strategic resource. It preserved food in a climate where spoilage could happen within hours. It provided relief during extreme heat. It supported trade, social life, and even medicine. The ability to produce and store ice meant control over comfort and survival in a place where both were constantly under threat. What makes the Yakchal remarkable is its longevity. These structures appeared as early as 400 BCE and continued to be used for centuries. Their design did not disappear with time. In fact, the concept endured so deeply in the culture that even today, the word for refrigerator in parts of the region remains Yakchal. That continuity tells you something important. This wasn't just effective, it was foundational. To understand why the Yakchal worked, you have to stop thinking of it as architecture and start thinking of it as a machine. Every part had a role, and every role was essential. The first component was the massive shade wall. These weren't random barriers. They were carefully aligned, typically running east to west, so that during winter months, they cast a continuous shadow on one side. This shadow created a microclimate, an area significantly cooler than the surrounding desert. That difference in temperature was the starting point for ice production. Below these shaded areas, shallow pools were constructed. Water flowed into them, often carried from distant mountains through underground channels known as qanats. At night, something critical happened. The water began to lose heat, not to the air, but to the sky. This is where the genius of the system becomes clear. Even when nighttime temperatures stayed above freezing, the water in these pools could still turn to ice. This seems impossible until you understand the principle at work. In dry desert climates, the atmosphere contains very little moisture. That means there is less interference when heat escapes upward. The water radiates its heat into the open sky, effectively losing energy to the vast cold of space. As this happens, its temperature can drop below that of the surrounding air. Night after night, thin layers of ice form on the surface. These layers are harvested each morning, creating a steady accumulation. This wasn't guesswork. It was observation refined into method. The Persians didn't need modern terminology to understand radiative cooling. They mastered it through experience. Producing ice was only half the challenge. Keeping it from melting through the summer demanded a completely different level of design. This is where the iconic dome of the Yakchal comes into play. These domes were not built for aesthetics. Their shape served a purpose. Rising as high as 20 meters, they created a natural airflow system. Warm air inside the structure would rise and escape through an opening at the top, while cooler air settled downward into a deep underground chamber where the ice was stored. This underground pit was insulated by thick walls, sometimes over 2 meters wide. These walls slowed the transfer of heat to such an extent that it could take months for external temperatures to affect the interior. Combined with the airflow system, the result was a stable, cold environment that could preserve ice for half a year or more. Everything about the structure was intentional. There was no wasted design. The performance of the Yakchal depended heavily on what it was made of. The builders used a specialized material known as sarouge, a mixture that included clay, lime, ash, sand, and organic fibers like animal hair. To modern ears, it sounds primitive. In reality, it was highly advanced. The ash provided insulation. The fibers reinforced the structure, preventing cracks from spreading under thermal stress. Additives like egg whites created a smooth, water-resistant surface once dried. This was crucial. Any water seeping into the walls and freezing could cause internal damage. Sarouge prevented that entirely. The result was a material that could withstand extreme heat, resist water penetration, and remain structurally stable for centuries. Some of these structures are still standing today, which speaks for itself. Many Yakchals incorporated wind catchers, tall towers designed to capture and direct airflow. These structures pulled in even the slightest breeze and guided it downward into the storage chamber. Often this air passed over cool water from underground channels, lowering its temperature before entering the dome. This created a continuous cycle. Cool air moved in, warm air moved out. The system maintained itself without any external energy input. It was entirely passive, relying on natural forces that were always available. In survival terms, this is critical. A system that depends on nothing is a system that cannot fail due to lack of supply. When winter conditions were right, ice production became a coordinated effort. Workers monitored the pools, harvesting thin layers of ice each morning. These layers were transported into the storage chamber and stacked carefully. To prevent the ice from fusing into a single mass, insulating materials like straw or reeds were placed between layers. This allowed the ice to remain usable months later. The process continued until the storage pit was full. Once sealed, the Yakchal entered its preservation phase. The ice inside would remain untouched until the peak of summer, when it became one of the most valuable resources in the community. When the heat returned, the Yakchal transformed from a storage system into a distribution center. Ice was brought out and transported to markets, where it was used to cool drinks, preserve food, and create early forms of frozen desserts. What stands out is accessibility, because the system relied on natural processes rather than costly fuel or machinery. Ice was not restricted to elites. It was available to ordinary people. That democratization of comfort is something rarely seen in ancient technologies. This wasn't just survival, it was quality of life. Today, cooling systems consume a massive portion of global energy. In many regions, they are the difference between safety and danger during extreme heat. But they come at a cost, both economically and environmentally. The Yakchal represents a fundamentally different approach. It shows that cooling does not have to rely on constant energy input. It demonstrates that understanding natural processes can lead to solutions that are both effective and sustainable. Modern engineers are beginning to revisit these principles. Technologies that use radiative cooling, passive airflow, and thermal mass are gaining attention. The ideas are not new, they are rediscovered. That should tell you something important. Progress is not always forward. Sometimes it requires looking back. The story of the Yakchal is not just about ice. It is about intelligence applied to environment. It is about solving problems with precision rather than force. And it is about recognizing that some of the most effective solutions are already known. We've simply stopped paying attention. As temperatures rise and resources become strained, the relevance of this ancient system becomes clearer. It offers a blueprint not just for survival, but for resilience. If this kind of deep historical insight into real-world survival strategies is what you're here for, make sure you subscribe and share this with others who take history seriously. There's a lot more to uncover, and every lesson matters.